In this video, we will discuss the mode of Poisson distribution. By definition of mode, we mean that the most frequently occurring value among a set of observations. So naturally, the most frequently occurring value will have the probability with the high maximum probability. So in the values of the random variable following Poisson distribution, there is a value which attains the highest probability. That is, if x follows p of lambda, that is given by the equation p of x is equal to e raised to minus lambda, lambda raised to x by x factorial. If x has this distribution and the values 0, 1 to etc. Among the values 0, 1 to etc. there is a value with highest probability, and that value is stated to be the mode of Poisson distribution. We note that when x is 0, it is e raised to minus lambda, lambda raised to 0 by 0 factorial. When x is 1, e raised to minus lambda, lambda raised to 1 by 1 factorial. When x is 2, e raised to minus lambda, lambda square by 2 factorial, etc. So at one of these probabilities generated by this equation, by putting 0, 1 to etc., this probability becomes maximum. That maximizing point of or maximizing value of x is considered as the mode of Poisson distribution. So you will get a general equation in terms of lambda for getting the mode of Poisson distribution. So once we know the constant of the Poisson distribution without a separate derivation for mode, that constant from the constant of Poisson distribution we can obtain its mode. So we can derive that a set of limits within which the mod will belong or mod will lie. So we can see that in Poisson distribution, mod lies within the two limits lambda minus 1 and lambda. That is, mod lies within the two limits lambda minus 1 and lambda. So we have here this lambda minus 1 and lambda minus 1 less than or equal to x0 less than or equal to lambda, or x0 is supposed to be the value at which probability becomes maximum, the value of the random variable x at which probability becomes maximum. That is, x0 is one of the values among the 0, 1 to etc. We can obtain a relation, not a relation, a set of limits within which x0 will belong, that is the limits of lambda minus 1 and lambda. So this equation can be, this is not actually equation, these limits will be, the limits will offer mode of Poisson distribution. We can note that these limits are two consecutive numbers, lambda minus 1 and lambda. So consecutive numbers. So suppose lambda is a whole number. Lambda is a whole number means lambda minus 1 is also a whole number. So therefore, in that situation, we say Poisson distribution has two modes. It's a bimodal. That is, if lambda equals 5, lambda minus 1 is 4. Therefore, the mode lies between 4 and 5, or mode will appear at 4 and 5, or the probabilities are highest. Probabilities are at 4 and 5, the probabilities are maximum. That's how we have the mode of Poisson distribution using the limits lambda minus 1 and lambda. At the same time, the lambda cannot be always a whole number. It cannot be. Say maybe some decimal with some decimal values, because lambda is actually the mean of Poisson distribution. Mean of Poisson distribution may be any number greater than 0 here, that may be a non-integer, a non-whole number also. So if it's a non-whole number like some 2.85 or 3.25, lambda 2.85 means lambda minus 1 is 1.85. So that if lambda minus 1 is a non-whole number, lambda is a non-whole number, lambda minus 1 also will be a non-whole number. Therefore, there is only one whole number in between those two limits, lambda minus 1 and lambda. And that is the mode of Poisson distribution. So Poisson distribution is unimodal if lambda is a non-whole number, and lambda is a Poisson distribution is bimodal then when lambda is a whole number. Therefore, the Poisson distribution mode may be uni or bi according to the value of lambda. That's how the mode of Poisson distribution. We can also consider this graphical mode of Poisson distribution graphically. For that, we have a set of slides showing the graph of Poisson distribution. Yes. So this is a situation where lambda equal to 2.75. So lambda 2.75 means lambda minus 1 is 1.75. So it is more lies between lambda minus 1 and lambda. So this is 1.75 and 2.75. So more lies between 1.75 and 2.75. We note that between these 1.75 and 2.75, there is only one value for the random variable x which follows Poisson distribution. And that value is 2. So we have a 2, the highest probability. The probability becomes maximum at x equal to 2. We get its value here given in the probabilities. The probabilities are listed here. At 0, 0.063. At 1, it is 0.175. And at 2, it has the highest probability, 0.24172. So this 0.24172 is the maximum, the highest probability among the probabilities listed here, and therefore the mode of Poisson distribution is at 2, or this is a case of unimodal Poisson distribution. The next graph will show a case of bimodal. We take x follows p of 4. Here lambda is 4, which is a whole number. Since lambda is a whole number, lambda minus 1 is also a whole number. That is 4 minus 1, which is 3. Which means that this 3 and 4 we have the highest probability. You can see the graph with the maximum height occurring at 3 and 4. In the values probabilities listed here, it is 0.19536 and 0.19536, which are the probabilities at 3 and 4. We see that the probabilities at 3 and 4 are same, and they are the probabilities among these probabilities with the highest value. So at 3 and 4 the highest probability occurs. That's why the Poisson distribution has the graph has highest probabilities here, and this is a case of bimodal. So Poisson distribution may be unimodal or bimodal. That's about the mode of Poisson distribution. Now we come to the last property of Poisson distribution, known as the additive property of Poisson distribution. Again, it's a very interesting property of Poisson distribution. The property says that if there are two independent random variables, each of them follows Poisson distribution with parameters lambda 1 and lambda 2, then the sum of these random variables also has Poisson distribution with parameter lambda 1 plus lambda 2. This is a very outstanding property of Poisson distribution, that is that summands have Poisson distribution indicates that sum of the variables also has Poisson distribution. So that is very much applicable in finding probabilities of probability distribution of sum of different Poisson random variables. Or we can, if you know the average of if we know the random variable with the Poisson distribution with some average, using that known average, we can calculate or we can identify distribution of any fraction of that time also. That means the random variable representing the fraction of that time has also Poisson distribution with average as the same fraction of the average of the original random variable. Therefore, if x follows Poisson with parameter lambda 1, and this y not x here, that is to be corrected, this is not x, so x follows Poisson with parameter lambda 1, y follows Poisson with parameter lambda 2, then x plus y also has Poisson distribution with parameter lambda 1 plus lambda 2. That's about the additive property of Poisson distribution. With this we complete all the properties of Poisson distribution. Thank you.